can see you, yeah.
Let's get it over and done with. Come on.
Let's get it recorded. I'll share my screen and then I'll share the presentation. Oh my God. It's a bit slow, isn't it? Share, run, do something. Oh, there we go. I can see you, but I can't see me, but let's just get started.
Well, I can see you and not see me, so we'll be all right.
Welcome everybody. We're going to look at ping today. Not quite sure why we've got 3 actual exclamation marks, but we do. It's all exciting. So we've got myself, Bryony, and we've got Rebecca as well. We're here today to talk to you about ping and the purpose of it.
Hi
And
there.
as always, supported by Andrew and Elizabeth. Just got their smiling faces in the pictures because they don't do the webinars as often as you get us, I think. Reintroduction. We're at the stage now where you've made a network. You did that last week. You should have a functioning network in some capacity. And it usually works. Although if you're using Packet Tracer, that's a questionable statement, isn't it, Rebecca? With Packet Tracer?
Sometimes, most of the time, it does.
Yeah. But one thing you need
It's
to think
usually my own mistake if something has gone wrong.
Yeah, definitely. Typing in IP addresses. One thing we need to think about is how do we actually troubleshoot this network because things go wrong. And what are our first steps? So you may look like the person in this picture a bit frustrated when you're trying to fix things and try to work out what's happening. And one little tool that we have is ping. It's a quick way of finding out what's happening between your computer and a server on the internet. And it gives you information that lets you see what's happening and you can try and troubleshoot from that. So how it works is that your computer sends a little message to another computer to say, hello, are you there? And that computer replies back to say, yeah, I'm here. Or it could reply back and say, no, I'm not here. But you might not get a reply in that sense. And what your computer does is it measures how long that message takes to come back. And that's called the return trip time, RTT, because we love acronyms in computing. Faster, that connection, that reply tells you how fast or slow your connection is. So the shorter that time, your RTT, the faster your connection. Got an example in the site here where we've just used the command ping and we've decided to ping Netacad. And you can see the replies and the time that it takes to come back. You get some little extra information down the bottom. We'll talk about that. Rebecca's got a nice little demo to show you as well. We'll talk about sometimes packets can disappear. They just vanish into thin air. But with this one that we did, all packets were sent, all packets were received, and we've got our times. So our approximate time down the bottom, 13 milliseconds. It's quite nice. ICMP. On you go.
All I was going to say is I think I'm anticipating. I was going to say sometimes it's called an echo request because you can see because what it's doing is it's sending out like 4 little bit like when you have a radar in an old-fashioned submarine and it goes ping ping and it waits to see how long it comes back, and then we'll have a look at a bit of something called trace route, and it's sort of it's waiting for the echo to come back and seeing how long it takes to come back along all the wires. So it's basically it's doing testing connectivity between 2 points, either on an internal network or indeed externally as well.
Yeah, that's a good example, having an echo. I like that. ICMP is Internet Control Message Protocol, and that is, words to put it, special messenger on the internet that helps the computers communicate with each other. And it works at the network layer if you've looked at the OSI model. It works in a similar way. When that ping's sent, it's ICMP that's being used to say, hello, are you there? It helps the computers and servers to communicate about network problems. It's connectionless. So if you remember the lesson we did a few weeks ago on UDP and TCP, it doesn't need to set up this connection. It doesn't have to do that handshake. It doesn't really care about that handshake. And it doesn't allow for targeting a specific port on a device. We're just wanting to see whether that device replies. Are these things important? Well, yeah. We need to be able to use it to check our connection strength, to check our speeds, to check we've got a connection in the first place. If you delve into the realm of troubleshooting, you usually look at the simple things first, usually physical, like is your cable plugged in? But after that, you want to make sure, is there an actual connection? Because that could then mean there's something wrong with your hardware. It could mean something's blocking it somewhere. And ping is one of the best tools you can use for that because it's simple. It's 4 letters and then you pick your target. Can help us find out where the issue is, especially if we use trace route, which is coming up in a second. And it can allow us to monitor network performance because you can check connections between all of your devices and see where you've got any issues, any barriers, any traffic jams. The fancy word for that in computing is bottlenecks. I prefer traffic jams. Then it helps you be able to fix it. Some examples. Online gaming, we all do that. If you've got a low ping, that's less lag. That means your game's working a little bit better, but high ping means you've got massive delays. And if you want to look at some controversial information about ping and gaming, then feel free to Google it, because I did that earlier. And apparently, looking at your ping rates is very well used in gaming and against your competitors. So not that I would advise to do that. Same with video calls. If you've got a high ping, you get that glitch and delay in the video calls, and we're very much an online environment these days. So that's very frustrating when you're trying to have a conversation and your video's vanished or your audio's vanished. Thoughts about traceroute? It's a nifty little tool that shows us the path that ping is taking or that information's taking. In this example, we just traceroute for Google, and you can see all of the hops. So it's quite interesting when you look into it in lots of detail. If you do this at home, it'll be different results that you get from what I got. If Rebecca did this right now as well from where she is, she'd get different results to what I got as well. Another example here as well, this one, 2 different users from 2 different places have done a traceroute for Netacad, and you can see the differences. Now these were done within about 5 minutes of each other. And because we're in different locations, it's going through different devices and you're getting different speeds as well.
Now, what's interesting off that picture, if I can point out, because I don't know whether or not you guys have done IP version 4 addresses yet, but you might see where it changes from an internal address to an external address, so what's called a public or a private IP address. So if you'd like take a look at the top picture with the trace route, when I'm on 172 at the beginning and 172.16, I can see I'm still inside the LAN. So because there's a series of addresses, there's 10 something 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 172.16 to 172.31 something something. And then in a 192.168 address, which is probably what you have on your home computers. So if you were to try and go to command prompt or CMD here on your own computer and try to do a trace route to Netacad, you'd probably find your starting computer was on 192.168. It might be 1, it might be 0 dot something, and that's an internal network address. So usually that's reserved for inside your own little local area network. And then we can see when it starts to go outside, so it goes like past the router. So can you see how in the bottom picture, that's on and you can see it's on a different network because it starts from 10.2.2.2.1, which is the which is probably the gateway, and then it starts to go outside. And then you can see from that point onwards, those addresses are no longer internal addresses, and it starts to tell you where they are. So you've got, it's probably, is it Glasgow we're going through here in JanetNet?
Yep.
Yeah, and you can actually work out where those, so all of these addresses from this point onwards, 4, 5, 6 and stuff, well actually from 3 in the top one and the bottom one, they're all external or public IP addresses. So now we're on the internet on devices and intermediate devices on the internet. So you really can, and it's doing a DNS resolve to try and tell you the name of the computer or server that you're on to try and look up where you are. So you really can tell like exactly where. This is very useful for telling you where it stops or where the route breaks down if you're trying to get to somewhere.
Yeah, it builds up a nice picture, doesn't it? The VTB.
Yeah, it does.
Yeah,
I always find it quite intriguing working out like where you think it's gone, which route it's taken, and it's quite fascinating how long it takes milliseconds to get effectively hundreds and thousands of miles.
Yeah, it's quite interesting. We would say that though, wouldn't we? So from that, you can build a picture of where your information's going, and you can see all of the steps that it's going through, all of the hops that it's going through, and its final destination. You can see how long it's taking as well. There may be times where things time out, and that's just because it's taken too long for a response. And as Rebecca said, it will try and give you the actual name so you know where it's gone, not just an IP address, but not always possible. But one thing to think about before we finish the theory side of it is ping good or bad? So it's good for troubleshooting, and it's good for checking things work and making sure you've got that connection with another device. But there's kind of like a bad side to it, like using it in gameplay to your advantage against other teams. Rebecca's going to talk about in a little bit and show you some scanning of your internal networks and hosts and scanning external networks and hosts. If you are an unethical hacker, you may use tools around ping or mmap in this example that scans external and internal networks, and you use that to your advantage in a malicious manner. It's a little bit different if you're using it and you're using it, you work for that company, you use it to troubleshoot and try and preempt things. But if you're using it for a malicious manner, a tool that's meant to be made for good can be used for bad. Really? And on that, I think Rebecca's got a nice packet tracer to show you.
I have.
So
I am going to show you the good side today. I'm going to be well behaved. But absolutely, we talk about actually if you can throw your slide back for me, or if you are handed over.
Hang on, I'll put it back.
It doesn't matter. One of the first parts of when we're studying what's called the cyber kill chain, and we'd learn to think like an attacker, one of the first things on the cyber kill chain is recon or reconnaissance, and that's gathering information. So whilst the pings testing is really, really useful, and trace routes are really, really good for showing us and doing troubleshooting and showing where things break down, they can also be used to show us a couple of pieces of information, because they show us the routes and the pathways that things can take. They also show us what we could break, right, or what we could target or what we could attack, because they're effectively usually showing us gateways or routers or servers or endpoints, and they're showing us where things are. And they're also, to a certain degree, showing us that something is alive. So you might have been learning about denial of service attacks. So recon that a cyber attacker might do in the first instance might be to just like look at a network and examine a network and have a look by doing ping testing across the network to see what is alive there. They can pick out certain targets to make. And indeed, there's such a thing called a ping flood, where you try to send thousands and millions of pings over a very, very short period of time, and actually use up all the resources for that place. What's being shown in the picture there was an mmap scan, which is, it's showing you in that picture that you have a host 10, 0, 200.2 and 3 and 4 and 10 and 11 and 13 and 20. So those hosts exist. So if you wanted to try and get to them or try and navigate to them, then you could do so. So usually pings can be used for recon. So quite often places will actually stop people from doing ICMP inside the network. So you might find if you tried to do some pinging within your own business network, it may not allow you to do so on purpose to try and stop some of that recon stuff. Right, so let me see if I can share you my packet tracer. You might have to pass control to me if you can.
Yeah, there you go. That's you.
Thank you. If I share my entire screen, let's have a go. Right, and I'm going to jump over to a packet tracer, and I will ask you if you can see that for me, please, Bryony.
Yeah, I can.
Magic. So I don't know if you guys have ever seen the physical mode in packet tracer. I think most of the time we've been playing around with a logical mode, where we've maybe been building up networks where we just see it like this diagram up here. So we've seen it as routers and switches and computers, but the packet tracer is very powerful, and it actually has a little mode that actually, I have to admit, I do quite like it. It's fiddly because you're trying to pretend to plug cables and things in, but it lets you pick up a cable, and this is pretending to be a network rack. So they get really complicated really quickly, and it lets you sort of plug in cables. So this is a very tiny network that's representing this network that's up here in the top left-hand corner. So I've got this PCA that's sitting on this desk here that's got a plug going into the switch on port FA06. So, oops, sorry if I don't hover my mouse over things. The way switch ports work is they go, they not often go odd numbers on the top and even numbers on the bottom. So it's like 1, 2. I'm not going to be able to do that, am I? Well, I point to the mouse, but I don't know if you can see that it's like the 5th and the 6th position that I've got the actual plugs plugged in on them, which is exactly what's in the diagram. So that it really does pretend and act like a proper router cabinet and rack for you, which is really quite interesting. So it's pretending for us to be a real network without me having to drag a whole network into my video camera for you. So this is a typical network. Like most typical networks, this has got a problem on it. So somewhere there is an issue. Now they've given me all the nice addresses that should be configured, and it's got both IP version 4 and IP version 6 addresses on it. And then it's got, probably, I haven't looked how it's been configured, but it's got an external IP address on it over here that's pretending to be a web server. So a little bit like Bryony's pictures were showing you trying to ping cisco.com or something earlier. It's got a setup where I should be able to ping that. But it's broken. So the question becomes, can we use pings and trace routes to actually show us where things are broken in the first place? So if I come to the command prompt on the computer, and this is pretending to be, well, this is pretending to be this, and I don't know if, I think we've played with this in a previous, this is my own actual computer, and it's pretending in Packet Tracer to be, so can you see how I've got a 192.168.1.71 address? So it's these numbers that I suggested before. Now, so this computer's pretending to be a computer on a LAN for me. So this one's 192.168.1.10, and its gateway's 192.168.1.1. So far things are looking as if they are actually configured like the picture. So let's have a see. Let's try pinging this external address on 209.165.200.26, and we'll see if we have connectivity or not. I mean, I could just try, going on the web server or going on the internet to it, but what a ping test would show me is how far I could get, whether or not that would pass. Now, I sort of know this is going to fail because we know we've got issues, but actually the ping reply here is, reply is coming back from 64.100.0.1, which, if you can see on my diagram, is this network here. And it's actually that interface on the ISP, on that end of the ISP. So I suspect, but I can confirm that with a trace route, that I'm getting through router number 1, and my problem probably exists on the ISP's router. So this would be really helpful to me, because it would mean there's no point in me going to the ISP's router and trying to fix it. Sorry, the router number 1 and trying to fix it. It's probably further afield. So if I, sorry, I'm doing a trace route to the wrong number. If I do a trace route now to the same number I just did, so to 165.200.226, it'll give me a little bit more detail, and it's probably going to confirm my suspicions, which are indeed that it's not getting past that point. So that it's getting to 64.100.0.1, and I can cheat really, because I can see that that's the IP address that's been given to gigabit 000 of the ISP. But what you would normally do is then at that point, what you might actually do is try to secure shell or effectively remote log onto the place that has a problem. So what this is doing is it's showing me where to go to get the problem. So I'm going to press Control and C, because it is failing. And then what I'm going to do is I'm going to remote log onto that device. So this is assuming you have administrative rights to do this, of course, because otherwise you're accessing things that you don't have rights to do so, which would not be fair or not be right to do. Have I got that right? Have I got the right addresses? Yeah. Oh, have I just been in more and put a... Yeah, there we go. And I think, there we go. So now I'm on the ISP. So I've got myself onto the ISP's router. And there's a couple of things that you can do. And I mean, this is more now troubleshooting than anything else. But one of the commands is show IP int brief, will show me the interfaces briefly. And if I'm having a look at the picture here and having a look at the interfaces that I've got, then what I'm noticing is this was supposed to be a link here to an external address. So gigabit 001 was supposed to be going off to this external web server here. But actually, if I look carefully, what's actually happening there is that looks like one of the internal addresses again. This looks like a 192.168 address. So it looks like it's going to a Class C network rather than going to the external address. So what I could do is let's have a quick look what it should have been. And I suspect that IP address has been misconfigured, which indeed it has. Now, so what we're going to do is we're going to fix it. So if we go to config, don't worry, you don't need to know how to do this part as of yet, but I can show you how you do it anyway. So I'm going to go onto the interface. I'll be very lazy because I think they have actually given me a copy of the addresses somewhere, but I'm here now. And that link there should be 209.165.200.225. This /27, this is a human way of explaining what's called a subnet mask. So it means there's 27 ones in a row in binary make up the subnet mask. So 255 is 8 ones in a row in a subnet mask. So in decimal. So 255, 255, and 255 is 24 of them. It is 8, then another 8 is 16, then another 8 is 24. And 25, 26, 27 is actually the number 224 in decimal because it's 1 1, it's 3 ones, 24, 25, 26, 27, and then another 5 zeros. I could have been really lazy and not worked that out because it actually tells me that number down here. But I know what subnet masks look like. So that's me adding that or correcting that IP address. And oops, I've just realized we've got IP version 6 addresses on here, haven't we, as well? I tell you what we'll do, we'll fix one at a time. We'll do one thing at a time. So I think that will have fixed my issue. If I come off that connection and try my ping again, by the way, I'm using the up arrow. It's a bit of a shortcut to just recall the history of the things that I've already put in. Now, fingers crossed. There you go. So now it's working, and now I know that I have actually fixed my IP version 4 address problem. So now this computer PCA can now reach the ISP and the external. I think it's supposed to be a web server. Interestingly then, so we saw there was IP version 6 addresses as well. But in the diagram up here, this IP version 6 address, which I didn't fix. So we can do the same thing for IP version 6 addresses, and maybe you've been talking about those. These are the longer addresses that are 128 bits long. If I try pinging that, because I didn't fix that, I think that will still be broken. And again, so it's showing me that it's timing out. It's helpful to me. And then actually what I can do is I can, if I do the trace route version instead of a ping version, it helps me to see it's going to be the same place. This time, can you see how it's giving me where it's failing as an IP version 6 address? And actually so it's failing at ACAD on .1, which I have a sneaky suspicion is probably, yeah, there, sure enough, it's there. It's on that interface of the ISP again. So it's getting to there and not getting across the ISP's router. So we could fix, I can go back and fix it the same way. Log back on using It would be really helpful if I stopped to type in a 1 instead of an L, wouldn't it? Or the other way around. I didn't like that. Oh, it's sorry, I do beg your pardon. It's because I've got a that on the end of it. That didn't help, did it? There we go. Right, so I'm back on the router again. So config T to move to configuration mode. Go back on that interface that goes to the external web server. And this time I want to correct an IP version 6 address. I should probably have copied this because it will take me ages to write it longhand. I'd just be lazy. Actually, my typing is possibly faster than, but I can be lazy and copy it out of there. And if I fix it, didn't like me doing that, did it?
No, because it's an IPv4 address, isn't it? So.
Oh, sorry. It would have been helpful if I copied. Thank you.
Sorry.
It's been a long day.
At its finest.
It would have been helpful if I'd copied the right address when I was copying it across. See, that's the wonders of troubleshooting for you. You can make your own mistakes as you go along. And this address that's underneath here, we may as well add this while we're here. This one is IP version 6 has its own version of, they're a linked local address. They're not quite equivalent to the internal private addresses, but they do a similar job. So that's that FE80. An IP version 6 address that starts with 2001 to 2003 is a global unique address, and this FE80 is like an inside address. So we should, in theory, have fixed that as well now. I come all the way out again, and if I now try my trace route, I'm assuming it might, there you go, boom, it got all the way there. So you can really use it to sort of to demonstrate connectivity problems a lot. Actually, let's go back to pinging. Let's just ping the IP version 4 address, and I'm just going to change it so that it's got an endless ping. So if you do an extended ping, it will now just keep pinging indefinitely. So it will keep pinging it in that window, which currently works until I tell it to stop, really. So I just wanted to show you that if I do something weird to my network, like let's just see if I can unplug that plug and plug it in there. I don't know if you saw me do that, but you see how the light is orange? So what I'm expecting is exactly what's happening over here. I've effectively brought down layer 1. So at some point I've unplugged it and then I've plugged it back in again. But spanning tree protocol and the switch will take a little while to recognize that it's plugged back in again. You'll see that light go green, and a few seconds later, you'll probably see my ping will be successful again. I could fast forward this, but I'm not going to because I'd like you to see the lights actually happen. So now light's gone back on the switch, the ping's still failing, and there you go, it's fixed it again. So you can see, I mean, that's genuinely what would actually happen in reality. You could actually see whether or not things are or aren't happening on the fly. And then this kind of thing, pinging indefinitely, this would be like a baby version of a kind of a ping flood. You can see how this could be manipulated, though. If I let it, could use up system resources if I let it do this, not a lot faster than it's doing it currently, or if I left it doing it, the device it's trying to reach is actually I'll sort of stop it now at this point. The device it's trying to reach is actually being held up by doing it. So similarly, you can actually use ping and ping floods to take advantage of a network to try and do denial of service attacks. There's ping sweeps where you try to change the size of a ping, so actually it's beyond the maximum size that it's expecting, that can cause problems. You can use Nmap to just have a look at a network and do some recon attacks and see which kind of things are there and what they are and whether or not they're useful for attacking. And there's even things where you can actually you can disguise if you've ever taken over a network. So if a cyber attacker has managed to get access to a network and come onto a network, and then they've found some information. So say they found the credit card numbers of customers or some sort of data that they actually wanted to breach and wanted to get out of the organization. It's normally not, it would trigger off almost all the incident response sort of software and what's called security information event management programs that are on the network. If you just sent the data straight out of the network, especially if it's large, it tends to, so they hide it inside things, inside normal looking traffic. So there's quite a lot of cyber attacks as well, that once you've already got into the network and then need to get the secret information out of it, you might hide it inside ping requests. And I wanted to get Wireshark open and perhaps show you some of that so you can see them when they're it looks like ordinary traffic and it looks like ordinary pings, but when you look inside it, it's not, doesn't look like an ordinary ping packet. But maybe we'll save that for another time. And you can do that with also with things like DNS requests and stuff. So you actually put little extra pieces of information and they send the data that they want out of the network, tiny, tiny, tiny secret bit by bit, hidden inside what looks like ordinary network traffic. So that was just an introduction, and we've sort of showed you how it can be used for good and for helping you to troubleshoot a network versus how it might be taken advantage of.
Yeah. And we're the last session, I think. Next week's the roundup. So
wow, we're nearly there. Well done you.
Definitely.
Yeah. So hopefully you'll have enjoyed yourself. And then if you're not, what you want to be doing then is kind of like, progressing yourself as much as possible through the materials. And yeah.
And thanks for joining us.
Thanks very much indeed. All the very best, everybody.
Yeah. I'm going to stop recording.